It's also streamed at the same time. And uh-oh. All right, looks like we're going back to Discord because my Zoom client just died, and because I was the only host, um, that took the Zoom room with me. I think I just took the entire room down when I crashed, in Zoom. So back to Discord. I'm sending that announcement right now, and just so that people know that they're supposed to be switching back to Discord. Oh, okay. All right, so there we go. I suppose that can be done. I mean, that's how asynchronous classes are conducted, right? I mean, you you guys have your own lectures, being going on. And this is why I cannot teach asynchronous class because I don't know how to do that. How am I supposed to lecture? How is a lecture supposed to be done when it is asynchronous? When I'm not even online with you guys at the same time. So so that's just a little. It's just a little weird to me. Alrighty. So I think we are good here. I just wanted to do the screen share through Discord. And let's see, where's my OBS? It's right here. And there we go. Go live. All right. All right. So, I am seeing about 15 people, back on Discord, and hopefully, the rest will get my message, my announcement, and then get back onto Discord, or, they may be joining me using YouTube. So let me switch to my YouTube tab and see what's going on over there. Yeah, we got 6 people on YouTube, so those people can switch back to Discord, anytime they want to. Alrighty. So YouTube is streaming. Yeah, YouTube also has a chat option, but I think Discord is back now. Um, okay. Uh, this is this is not good. Um, so YouTube seems to be the best platform at this point, because my Zoom just died, um, right there. Um, we'll see. Okay. Yeah, I cannot tell whether this Discord Go Live is working or not. It seems to be working from my end. I seem to be streaming, and there's no complaint, on this side. Okay, all right. Okay, excellent. All right, so this is how I'm gonna do it for now. Until I, actually get some serious error messages from Discord. Is if you want to join the class, through YouTube, you can do that. If you want to join the class, through Discord, that's fine too. But I'm not doing Zoom for the time being. So it's either YouTube or Discord, and I'm reading the text chat from Discord only. So I'm not looking at the chat from YouTube. So for all the text traffic, please try to use Discord. Unless Discord is dead again, then we're gonna switch to YouTube entirely. So that's kind of how we're gonna do it for the time being. We'll see, whether things will change, shortly. All right. So first thing first, prerequisite and co-requisite requirements for this class are important. So if you have a 0 point, okay, and you have not turned in a copy of your prerequisite challenge for Math 370 or Math 372, please do so as soon as possible, because that's supposed to be due today, and I can extend that maybe until the end of today. And then there's also the CISP440, which is a co-requisite requirement. This one I'm allowing people to, I'm letting people to try to get into CISP430, to meet this co-requisite requirement. And as a result, the due date is next week sometime. I think that's next Wednesday, sorry. So there you go. Okay, yeah, YouTube, if it's only 4 to 5 seconds behind, that's actually pretty good. And then Nathan quoted, okay, so they're imposing a limit of how many people can log on using Discord at this point. All right, cool. And let me take a look at the streaming side on YouTube. Okay, that seems to be going okay. I'm just trying to find out, whether I can, how easy is it to kind of keep track of the text chats on both Discord and also YouTube. Alright, so when my browser is actually doing its own thing, we can now move ahead and continue our discussion. So we are moving on to quantifiers now. So let's see, let's move on to here. And we are now moving on to basic quantifiers. So quantifiers are very important in this class because a lot of time when we want to express an algorithm or when we want to define a certain property, we actually utilize quantifiers. So quantifiers, there are two main types of quantifiers. There's one that looks like an A that is inverted, vertically, and the other one looks like a E that is also inverted, but this time it's inverted horizontally. So these two are quantifiers. The one that looks like an A kind of flipped upside down is for all. So you can kind of remember that because all ALL starts with the letter of A, and then the other one that looks like a little E but it's flipped horizontally is exists. There exists, and E is the first letter of exist. So that's kind of one quick way to remember which one is which one. So I'm going to start with the basics here. And I am okay, I'm actually looking at the text channel. There's nothing in the text channel right now. It seems to be active. I mean, Discord seems to be still working. So I'm not too concerned until people let me know that something is not right. Of course, the question is, how would people tell me that something is not right, if this code itself is not working? But I think it's working. Okay. All right. So right here we have, to make our discussions more concise, let's consider variable x to refer to a thing that we're examining. And p of x is some kind of Boolean function, otherwise known as a predicate. So p of x is a predicate. And when I use the term predicate, it really just means it's a function that returns a Boolean. It takes a parameter, or it takes several parameters potentially, and there's no restriction to what the types of the parameters need to be, but there is a restriction of what is the return type of the function. It has to return a Boolean value, which is either true or false. So when we look at this notation here for all x p of x, it basically is saying, the entire expression, the entire quantified expression is true if and only if for every x that exists in the entire universe, p of x is true. Okay, so let's just kind of pause here, okay, and kind of think about what this means. And I am fairly sure that some people will have a question about, what do you mean by in the entire universe? So I'm gonna pause here because there's a lag time of 5 seconds, on YouTube, and I'll let people have some time to digest this and ask questions if they need to. So go ahead and ask questions in Discord if you can, and I'm trying to navigate to Oh, okay. Somebody just asked me a question in Canvas. Okay, so let me address that. All right, so and I can direct them to the YouTube link. So let me get back to the YouTube link here. All right, so there you go. And this is the other one, probably the same thing. So I'm gonna paste that too. There we go. All right. So it looks like I'm just looking into Discord and find out, it may not be working 100%. I think some people are still having problems. Yeah. Okay. So let me put it into the announcement, so this way people can find the YouTube link for sure. And there we go. All right, so there we go. Tax channel. Oh, okay. Yep. Alrighty. And let me go to YouTube and see if I can get to the chat of the live stream. I've never done this before, and that's why I'm exploring right now. Okay, so all right. So how do I get to the chat? Okay. Okay, you guys can help me out a little bit here, because I'm not used to YouTube, or at least text chatting in YouTube with this live stream. Oh, they're disabled. Oh, they're only comments. Okay, so, all right. All right, so I got you there. I got you there. Okay, so the question is, can I change that without interrupting the stream? There we go. Okay, so allow commenting. Click save. There we go. Alright, so now that it should have commenting turned on. Oh, I just remember one thing, it's just now that I remember. Chat is disabled. Okay, so let me go back and change that too. Oh, right there. Live chat. There we go. And we'll enable that too. Save. Alright. So now, let me see if I can get to the text chat on YouTube. Alright. Yeah, it does work, but I need to find where I can find the text chats, right? So there we go. All right. And the chats are right. Okay, got it. All right. Cool. All right. So now I have to keep track of both Discord, because some people managed to get onto Discord and other people could not get onto Discord because Discord is basically throttling connections to Discord. So I'm doing both. I'm actually looking at both. Now, obviously, I have no idea who is Robot Ray. So when you ask, well, I suppose you can just go ahead and ask questions. I mean, even though the video is public, I really doubt someone other than in this class is gonna go watch that, unless they live in, let's see, maybe China, and they have insomnia and need something to help them sleep, so they might be watching YouTube, my YouTube, in that case, just to sleep a little bit easier. All right, cool. So I think we finally got the infrastructure done, and now we can get back to the notes, get back to the discussion of the Universal Quantifier. There we go. Oh. Oh, okay. That's interesting. I did not know. I did not know that people actually talk about my video on Reddit. I just thought most people would even forget the content, right after a class, let alone talking about it somewhere else. Anyhow, just keeping an eye on stuff here. Fell asleep right away. Yep. Okay, I can see that. I can totally see that. All right, so getting back here, and so universal quantifier. So the universal quantifier, in this case, it doesn't restrict, what this x can be. It is simply saying, whatever you can bind this variable x to, whatever value you can bind it to, p of x needs to be true. Now, obviously, this is useless, right? I mean, this kind of statement is useless because p of x usually is something that is meaningful. Like, okay, I'm going to return true if and only if x is an even number. But if x is not even a number, then why would I even care whether it's even or not? So we'll later on we'll talk about a filtering mechanism so that we can focus on just the things that we want to look at. But as it is right now, the universal quantifier applies to everything in the entire universe. Okay. Um, Well, okay, so let's take that, is a mammal. So if p of x returns true if and only if x is a mammal, this universal quantifier is actually going to apply things that are not even animal to begin with. It's going to apply things like, Boolean expression and say, okay, is this Boolean expression a mammal? Which doesn't seem to make sense, right? Because we want to kind of restrict is a mammal, to at least animals, right? I mean, it doesn't make sense to ask the question when X is a plant. So we'll talk about the filtering mechanism where we can say, okay, we want to find out whether P of X is true or false, but only to things from this particular set of things that we want to focus on. The next one is there exists. So this particular expression is basically saying, of all the things in the entire universe, at least one of those things will make P of X true. Okay, so it's just saying that at least one. Okay, so there exists is basically saying there's at least one thing that can make the predicate true. All right, so moving on to the next one is, you can apply negation. So when you apply negation to a existential quantifier, it would be the same thing as moving the negation into the predicate itself. So when the negation originally applies to the existential quantifier, you can move the negation to the predicate so that we are basically saying the negation of P of X, but then you also have to change the existential quantifier that was being negated into a universal quantifier. So if you just kind of look at the English version of these things, which is saying this one here is saying it is not the case that there exists something X such that X lasts forever. That's assuming P of X, is saying X lasts forever. Then we can change the way we express it and say that everything in the entire universe do not exist forever. So these two are basically saying exactly the same thing, because the first one says nothing lasts forever. The second thing says everything will eventually break down, and they mean exactly the same thing. So are we good with this negation? Why these two expressions are really saying the same thing? And I'm reading the YouTube chat here. Like with any value other than 0. I'm not really sure when that comment applies to. There's something in the universe that makes it false. This one, no. This one says, it is not the case that there's one thing that makes P true. That means everything in the entire universe makes P false. So that's how these two relate. All right. I'm waiting for like the 5-second lag, because there's always a lag in YouTube at least. Okay, that doesn't seem to be any questions for that. All right, so I'm gonna move on to the next one. So if the negation was originally applied to the universal quantifier, which is basically saying it is not the case that for every x, P of x is true, then you can do about the same thing. You move the negation into the predicate, so you're negating the predicate itself and not negating the quantifier. But then you also have to change the quantifier from a universal quantifier. For all is also called the universal quantifier, and then there exists is called the existential quantifier. So you can also do the same trick by moving the negation into the predicate, but then you have to change the quantifier from a universal quantifier in this case into an existential quantifier. So let me just kind of pause for at least 5 seconds so that if anyone has any question, you can go ahead and let me know. And backwards E means there's at least one. Yes, It means, yeah, that there's at least one thing, and in this case of the entire universe, that, whatever the predicate is, makes it true. All right. I'm not seeing any questions in either Discord nor YouTube. Yeah. Okay, so for all is really just this. Okay, for all x, p of x is true. So the negation um, is a separate part. Okay, so this is the actual, just this is the quantifier. The for all is called a quantifier, and then this entire thing is called a quantified expression because the variable x is quantified. Sure. And then this one is called the existential quantifier. And then Chris is typing something in the Discord channel. Negation is, it is not the case that. Yep, exactly. So the negation is this part here. This little symbol here is the negation, and that little symbol, the negation, is why we have this thing here. That is basically the long way of explaining the logical negation symbol. And then this, the E is there exists something x, and then p of x is such that p of x is true. In this case, p of x is x lasts forever. Alrighty. Okay, so I think we got that down so far. Okay. All right, so the next section, in section 4, if you have any questions about section 3, do not hesitate to type your question. You can even direct message me. Unfortunately, direct message may not work because Discord is still not 100%. I think it's back now. Yeah, for the most part. So, and Nathan just posted something. Next update in 15 minutes. This is funny because we are in the middle of a lecture, and Discord is fixing its services. And this is, to be fair, this is the very first time that I have experienced server-side issues with Discord. There were a few times when I got some client-side problems. That's just probably bugs that they had. They did not remove. Yeah, I think so. I think for the most part they are pretty good. I mean, I cannot complain. All right, so filtering. Okay, so the question is, if I really just want to say, what I'm about to say, needs to apply to only a small set. So this particular discussion here is really kind of abstract. So I'm going to change it, in my live note here to something else. So this is my live node, and let me change it so that it doesn't do the dark theme thing. There we go. And then I'll give you this really kind of specific example. So the first thing we'll do is I'm going to define a set. Okay, so I'll define this set called C because it's about cars. And we're going to put in some cars here. We're going to put in MX5. Whoops. The backslash went to the wrong place. So we got an MX5, we got an Odyssey, Odyssey. Okay, that doesn't sound right. Okay, fine, Sienna. A minivan. We'll put a truck here, Tundra. Okay, and then we'll put something else. We'll put an MR2. And another, minivan, Caravan. Okay, Dodge Caravan. That's from way back when. Fiero. Okay, fine. We'll put in a Fiero. I think most people in this class, okay, first of all, most people these days, most young people these days do not, they're not car people. They don't go and go like, oh, what is this car? What kind of engine do you have in the car? What kind of mods have you done? People look at cars these days like, I don't even want to own a car. I can just call a Lyft. Why do I want to own a car, right? If you want explosions, we want to put in Pintos too. Yeah, but that's like really way back when. Yes, I can see Discord is back. All right, so if this is the set C, then I can now define my predicate as well. So I'm gonna say P of X is true if and only if X is a two-seater. Okay, meaning that there are only two seats in the car. It doesn't really mean that you can only have two people, you can only carry two people at a time, including the driver. It just means that you can only safely transport two people at a time. Yeah, because the third person can be hanging onto the trunk of a two-seater. Just not very safe. Okay, so Nathan is updating again. The database healthy again, and our internal error rate has fallen to nominal levels. We're beginning to raise the login rate limit to allow users to reconnect. All right, so you guys can give it a try if you want to. I'm just reading the YouTube comments. All right. So this predicate P obviously really wants to apply only to cars, right? Because whether you have a two-seater or not, kind of implies that you're talking about cars. So things like animals, really should not apply. Like it doesn't make sense, to say whether my cat is a two-seater or not. So that means we don't really want to use a universal quantifier anymore without any restriction. So if I were to write a universal quantifier like this for all x p of x, that doesn't seem to make a whole lot of sense. Okay, in other words, I really just want to look at a set of vehicles, okay, types of vehicles, and I'm going to ask, are all of these vehicles two-seaters? Or is there at least one of these things that is not a two-seater? So we want to do some filtering. Oh, okay, Discord is still kind of not working. All right. So what we are going to do here is to say, if we, okay, let me start a new sentence, new paragraph. If we want to limit P of X to elements in C, we can do the following. So we're going to address the universal quantifier first. So we still want to say, are all the cars within a certain set, two-seaters? But this time, we want to restrict to only things in C. So there are two ways to do it. I'm going to first do it the long way, and then we'll talk about the shorthand way of doing this. So the longhand way of doing this is still going to do a usual for all, for all x. And we're going to use the parentheses. So we are still using the same notation as before. However, in this notation, we're going to use an implication so that we are quote-unquote filtering everything that are not from the set C, so that the predicate is really only applied to things that are in the set C in this case. So the way we're going to do this is to use implication. So implication is a right arrow. So we're going to use an implication, whereas the right hand side of the implication is still the same thing that we are interested in, is whether predicate P is true for X or not. But then, on the left hand side of the implication, we want to say, for those things that are not in the set C, I don't even want to care. Okay, so in this case, because we have a universal quantifier, when we say we don't care, we really just want to say that whatever is inside the parentheses here, inside the parenthesized expression, that really just should return a value of true for anything that is not even in the set C, because otherwise, it would interfere with the truth value of the entire quantified expression. So the way we do it here is to say, x in C. This is how we do the filtering. Okay, so let's think about this a little bit. Okay, so let's just say because x technically is still going to bind to everything in the entire universe. In other words, x can bind to a specific earthworm in my garden. Okay, but when x is binding to that specific earthworm, and I'm evaluating the expression inside the parentheses, the first thing it's going to be evaluated on is that earthworm an element of the set C over here? And the answer is no, right? So, and if the answer is no on the left hand side of an implication, what is the value of the implication itself? So let me just kind of ask you that question, because consider this as a little, it's not a quiz, it's really just a little checkup and see whether you guys are remembering the definition of implication. So if the left hand side of the implication operator is false, what is the value of the implication itself? And I can see Discord is back. Most people are replying through Discord, and that would be correct. So Elijah is correct. And then Enzo said if the predicate false, the implication is true. Not sure. Okay, I don't think that is the case. I think what Enzo meant was if the precedent of the implication is false, then the implication is true. In other words, the left-hand side of the implication operator is also called the precedent of the implication, not the predicate of the implication. All right, so my watch just buzzed me to remind me to take roll. I mean, you guys all saw, that I was planning to take roll today, right? I mean, right here. So I'm just going to uncheck that, and I think I set up the time already. And I'm going to type the words in both Discord and also on YouTube. So this way, either way you can see it. This is going to be better. I'm just going to type it somewhere here. Because that way, no matter which one you're using to watch, you can still see it. So there are two words that I have chosen to do the roll taking. That's another way that's even lazier to do this, and I'm gonna do it the laziest possible way. I have rolled d20. Not sure what that means. d20. Oh, okay, to roll a 20-side dice. Yep. Those dices are interesting. Just to have 20 sides, in a 3D shape, to have 20 sides and it's all uniform. That really is kind of interesting by itself too. Anyway, I'm going to show you the answers to this particular roll taking activity. You guys will like it, I think. Some of you. Alright, so it is existential and crisis. I'm going to paste those words. So if you want, you can use existential, just kind of copy and paste it. And then the other one is crisis. I'm not sure how many of you have done your personality test, like the Myers-Briggs type indicator test. According to that, people of my type, which is INTP, are particularly prone to having existential crises. Yeah, that's kind of funny. So there you go. Just copy and paste the word into the activity, and that's it for roll taking. Yes, yeah, just not both at the same time. just one of the two. No, nobody is having existential crises in this class. And then we want to say, but how do we express that as a quantified expression, if I want to say no one in text class is having an existential crisis, how do we express that? So we'll get to that in just a moment. All right. So we're back to this note here. This is how we do the filtering, and then we'll talk about the existential one, and then we'll go, we'll flip back, to talk about the example that I just came up. All right. So the next one is in an existential. When we use there exists, how do we limit, things to restrict to a particular subset? All right. So the original form looks like this. Okay. A one-sided die. That would be pretty hard to do. I mean, okay, yes, we can do it. A one-sided dice is a sphere. It's a little marble, right? Because the marble has one continuous surface. It doesn't have any line to say, okay, but this is one side and that's the other side. So, you can look at the sphere as a one-sided 3D object. One-sided die, but 2D. If it's 2D, if it's a 2D object, that's only one-sided, that would be a circle and instead of a sphere, because it only has one edge interfacing with everything that is outside of the circle in 2 dimension. All right, so this one is not quantified. It is quantified, but it's not applying to only a subset. In other words, I'm not asking, of all of these cars in the set, do we have at least one of these things being a two-seater? No, this one is asking, under the sun, in the entire universe, do we have at least one two-seater? And the answer is, yeah, well, there's that one that Elon Musk, sent to outer space. Yes, he did. Okay, Elon Musk sent one of his electric roadsters into outer space. But we are not talking about that one. We are talking about this very specific subset. So how do we restrict to a subset when we are using the existential quantifier? What is in the trunk? I was about to think, maybe some competition. But I think at that point in time, there's no competition. So, all right. So the question is, what operator are we going to use here? So I'm going to put a question mark, in place of the operator. And this part here is kind of easy, because we still want to apply the same kind of restriction. In other words, hey, if this thing is not an element of C, let's not even consider it, okay? But there's no way to not consider that, okay? Because the existential quantifier does apply to everything in the entire universe. So the question is, how can we make something that is not in C not to interfere with the result of what we intend to do, which is, we only want to apply P of X to elements of C. Everything else should not interfere with the answer. So this question mark here is not going to be an imply. Now, why is it not the imply? Because if it is an imply, that means everything that is not in C is going to make the existentially quantified statement true, right? Okay, so I just said something that is very specific and very technical, and even though you might be hearing every single word just fine, what is the meaning of what I just said? And Robot Ray from YouTube has the right answer using the AND operator. And okay, so I'm going to put in the AND operator first, and then we'll go back and kind of address why that is the case. Okay, so I'm going to use the mathematical symbol, the little inverted V symbol, as conjunction. So in this case, we're using conjunction and not implication. So let's think about what happens when X is not in C. If X is not in C, then X in C is going to be false, right? So is that going to cause problems? No, it's not going to cause any problems because it simply means, for that thing that is not even in C, um, the value of the expression inside the parentheses is going to be false. It's going to be okay because if we do have at least one thing in the set C that is in this case a two-seater, then we'll still be fine, right? Because we only need to have one thing, you know of the entire universe to meet this entire requirement here in order for the existentially quantified statement to be true. All right, so let's see if people have any questions. And if people do not have any questions, I can give you the equivalent code, to express both of these in JavaScript. Because I think when people actually see the code in JavaScript, they will actually go like, oh, okay, so now that we know how to express this in a procedural way, in an algorithm, I can follow that and understand the concept. So, but first of all, I just want to see if people have any questions about these two notations. And yeah. Sure. You mean the intention, or do you mean the actual word-by-word translation of the mathematical expression? Okay, I will try. So for the top one, it says for all x in the universe. Okay, so okay, just to be very clear, I'm gonna have to add this. Is it true that for all x in the universe, x is in set C implies x is a two-seater, and that's based on how we define p of x up here. All right, and then the second one, and I'm just tilting my head because the window that has the VI or the editor is somewhere else on the screen, and it was blocked by my half mirror. There we go. So this one is asking, once again, is it true that? But then, instead of saying for all, we are now saying there exists at least one, or we can say there is at least one x in the universe such that we just kind of spell out the expression inside the parentheses here. So such that x is in C and x is a two-seater. So that would be the literal translation. And for people who really don't want to use the phrase for all, you can say every. In other words, right here, the phrase for all is really the same thing as the much more common word of every. Yes, so the entire expression, this entire expression, can be true or false. This entire expression can also be true or false. Yep, absolutely. All right, so I'm looking at the text channel in Discord. Okay, so someone posted something in Discord and someone posted it in YouTube. So let me go through all of those questions. These are saying different things, right? Yes, they're stating entirely different things. One is basically asking, do we only have two-seaters? Basically, the top one is asking, do we only have two-seaters in the set C? And then the second one is asking, do we have at least one two-seater in the set C? So they are asking different questions. And then the next one in the Discord channel asks, so these are set up so that they return false or true for the appropriate situations. Yes, so each one, this entire thing, starting with the for all symbol, ending with this close parenthesis, it is really a Boolean expression. It returns a value that is either true or false. And the same with this one, except this one starts with the existential quantifier, ending with the closed parenthesis, but it's the same thing. It is by itself also a Boolean expression. It's either true or false. And then there's one more comment from the YouTube side, and it says correct answer to fun questions, two side, inside and outside. Oh, okay, I see. Okay, so that's a slightly different thing. All right, and Chris put into the general text channel of a free logic textbook. So we can take a look at that maybe after the class, but I think that's probably a good resource. Knowing this is coming from Phil, I have a lot of respect, for Phil. I mean, he is really good as a math professor and as a colleague. All right, so let me see what Chris has to say in the text channel, and then we're going to move on and look at these two things as an actual function in JavaScript. Alright, so Chris says, if you want something more verbose than text modules, that book is good. Okay, yeah, well, I have been accused of writing in a very concise way. And for the most part, I do not try to write things in a concise way. It just kind of happens that way. And it's basically, it's interesting, how the personality test, actually would tell you something, because if you look up the type INTP, that's one of the things, they say about INTPs, and for the most part, INTJs as well. So, if you have not done it, go ahead and do that, personality test. Because it's not for class purposes. Okay, it just has it's just a great thing to do, so that you can have really interesting conversations with your friends and telling each other what your types are, and so on and so forth. All right, so getting back to this, I'm going to give you a little bit of a JavaScript code. And remember, in JavaScript we have the concept of a object. That's it. I was looking for that word. So an object has members, so you can kind of look at an object as a set, and then each member is an element in the set. Okay, sort of. Okay, I'm not saying that they're exactly the same thing, but I'm just going to say that they're close to what we want to say here. Now, even though each member within an object has its own value, we don't care about the value. Okay, so we are not looking at an object as a map. We're looking at it as an object as really just a set. Okay, so now let's go ahead and take a look at what it means to be evaluating this expression here. So in JavaScript, I'm going to use a function to describe it. So we're going to say this is a function, and it says, for all. And it's going to take, two parameters. One parameter is to specify what object or quote-unquote set that we are dealing with. So we're going to say, in this case, I'm going to use lowercase s, for the set, and then the other one is the predicate, which is a function. So I'm passing the function in as p. There we go. So these are the two parameters. Now inside the function, we are going to have a local variable, and in JavaScript, the way you declare a local variable local to the scope itself is to use the keyword or the reserved word let. So we're going to say let here, and we're going to say return value or result. And in the case of for all, we are going to have a default value of true. Okay, and then at the end, we're going to return whatever value is in result at that time. So now the question is, what kind of logic do we use in between? So there's a control structure called a for in JavaScript that can go through all the members within an object. So we're going to say for, and we use let here to declare the local variable, which is examining an element E in the set S. So what this is going to do is, in no specific order, remember ordering is not important in a set. So I'm going to say without any specific ordering, it will basically look at every single member within the set S. And it's going to evaluate, or it's going to execute whatever statement is in between these two braces over here. So what we're going to do here is simply to say, result is result and, I'm going to use logical and here, whatever P of E is going to return. Now, if you want the symbols to resemble, what we have, in the statement here, I can do that. So we just have to change the parameters. Oops. We have to, yeah, I typed those 3 characters because I was using the VI command to try to move up, but I forgot that I was in edit mode and not in navigation mode. So whatever I type to try to move the cursor, appear as the content of the of the of the file. I just want to explain that. And then we're going to use x as the variable that we are evaluating. So this way, the use of x and the way that we use c will be consistent between the example here and also the code over here. All right, so do we have any questions about the JavaScript implementation of for all? And remember, for all is really the same thing as every. So we're going to say we can change this to every. I think every is going to be highlighted the same way, so it's not going to change. Do we have any questions about the JavaScript code? Okay, Nathan is typing something in Discord. Alright, so P in this case is going to test whether the predicate holds true for each element. So P is kind of like a function. If we are passing a function in to the function every. In JavaScript, functions are there's a term for that. It's very native. It's a very native type in JavaScript. You can pass it. Okay, all right. Yes. So, yep. Yep, exactly. So for those of you who want to kind of actually see how this executes, okay, this is way too small. Let me go find my other CLI, where the font is a little bit bigger so I can show you guys. Okay, I see it. It's all the way at the bottom of my tabs. There we go. Okay. So the thing about JavaScript, especially if you use Node, is it's really kind of interactive. I mean, you can do all kinds of fun stuff with it. So I can now say, let C equals to, and this is the object. So once again, because if it's an object, it's kind of like a set. It has all the interesting properties of a set, but then it has something more because in addition to each member being a member, each member also has its own value, which we don't really care, okay, in the context of this class, okay. So we're going to say, mr2, okay, so that would not be actually be a very good example here. I'm trying to find out, find an example. Okay, so because the objective is really just to show you how the for in loop works, so we'll go ahead and just do this. Okay, mr2 has a value of 1. Now remember, the value doesn't matter. Okay, I'm just I have to give it a value. In fact, I can just give it a value of undefined. Okay, I think that is okay. I think that's allowed. And then mx5 also has a value of undefined. Yeah, p of x is a function, but I will show you guys, how it's really cool that you can pass a function, an anonymous function in JavaScript, but it doesn't have to be that. So, but in this case, I just want to illustrate, how the loop structure works. Okay, the for in control structure. So we are not going to even be using p in this case. So we have this, and then we have Sienna. Okay, Sienna is also undefined. So the member is defined, but the value corresponding to the member is not. Okay, So now if we ask what is C, it gives us back the object. So now I can use the for in control structure. So now I can say for, and then I use let here because I'm actually using a local variable that has not existed before. So let is in JavaScript, if you don't turn on use strict, it doesn't really care. You can actually start to use a new local variable, and it just magically starts to exist when you mention its name. But that's not really a very good programming practice. You really want to turn on the enforcement of you can only use local variables that have been declared. So I'm going to say if x in, and we already have C as an object. Now we can just use the good old console.log, because console.log is just printf, okay, or cout, okay. For those of you who are familiar with C++, console.log is doing about the same thing as cout. And then Chris is saying the loop is iterating through each member of the set, which is basically an object. Yes. And in this case, we are not calling p of x. Okay, we are not calling anything because I'm just illustrating the control structure here. Luke then said, but is x in C well, okay, so we are not doing p of x just yet, okay? So we will deal with that later, but for the time being, we're just going to say, I just want to illustrate the control structure first, and then we'll deal with, passing a function in as something that we want to evaluate. So we're gonna make the program more complex, but not yet. Okay, so we're gonna say backtick in JavaScript means I can expand certain portions within the string into the value of the expression that is enclosed in $brace and brace. So we're gonna say there is member, okay, and then we'll spell out the name of the member, which is in X. And then that's all we want to do in the console.log, and then we close the brace, and therefore we are now concluding what to do for each x as a member of C. And then press the enter key, and this is what it says. So okay, let me just kind of pause here to make sure that we understand what the control structure is doing. The control structure is really just going through all the members within an object and bind each member of the object, just the name of it, okay, not the value, just the name of each member of the object to the local variable x, so that you can, for each iteration, then you can decide what do I want to do for a specific member within the object. So this is just illustrating the control structure itself. Are we good here? Maybe. We good? Yes? No? Maybe? Okay. All right, cool. All right, so then the next thing we want to do is to look at the entire thing. Okay, so to look at the entire thing, I think we can still do it like this. Yeah, because I can define the function on the fly. Okay, so we can. I'm still deciding whether to actually write a program or to continue with this interactive mode. We can do it either way. It's just that I just want to find out which way is the better way to do it. Okay, so I'm going to do it a little bit differently. So we'll define a different set. We'll call this one E. Oh, okay, finally. Cool. So I'm going to say E is an object. I'm not sure whether I can use an integer like this, as the name of a member. I really should know, but I don't. So we'll say this is undefined. Come on, undefined. There. Cannot type today. For undefined. And then we'll have 6 undefined. There we go. Okay, that works. Cool. So now we have a member called 2, one member called 4, and the last member called a 6. Okay, so you can just consider E as a set with 2, 4, 6 in it. So now I want to define, I want to see if everything in E is a even number or not. Okay, so that's what I want to do next. So we have a for, oh, right, we have to say let result equals to true. That's coming from the algorithm that I typed a little bit earlier. So you have to initialize result to be true first. Okay, and then we have a loop to go through every single member. So we say for and then let x in E in this case. So we are dealing with set E and not set S anymore. And then for each iteration, what we are doing is we are evaluating whether x is even or not. So now it is result gets result and E is even. So if we want to check whether it's even or not, we basically use the mod operator and see if the result of the mod is 0 or not. Because if we mod E with 2 and it returns a 0, that means E is an even number. And this is how we do it. Press the enter key and then we look at result, and result is false because E is probably considered a string, and string mod 2 is not gonna do what we think it's gonna do. Alright, so let me evaluate that first and see if that's the problem. So we're gonna quote 2 and mod it with 2. It does return a 0. That is, it is strange the result becomes false. Okay, I did something wrong here. Oh, you're right. Okay, thank you. Ivan is right. I just made a poo-poo here. I should be using x because we are applying the predicate to the member, to each element of the set and not to the entire set. There we go. And this time result needs to be reinitialized too. So result is reinitialized to true, and then we perform the loop again, and then we look at result, and this time it is true. There we go. Yeah, good catch. Good job. All right. So is that okay? I mean, does everybody kind of understand, how for all works? Okay. So I'm gonna throw you guys a curveball now, okay? Because I'm gonna say, what if the set is empty? So what if the set is empty? In other words, I'm gonna say E is an empty set, and yes, it has the same notation. Oh, we cannot say let anymore because E already exists, but we are reinitializing E to the empty object, which is analogous to our empty set. Okay. And now we want to reinitialize result to true again, right? Because that's what we're going to do in the subroutine. So every time you call this subroutine, result as a local variable is reinitialized to true. So now the question is, if I go back and reevaluate this particular control structure, what is going to happen to result? Well, you guys are going to say, but there's no element, there's no member in this E, so we are not going to go through one iteration, which means result doesn't even get a chance to get changed, which also means by the time this loop is done, result is still going to be true. So when we look at result, it is true. So this is kind of strange because it says, if you have an empty set and you are trying to apply the for all, and you're trying to filter everything through the empty set, the answer is it is going to be true. X in C is always false. Exactly. Yep, exactly. So Chris also has a different explanation of why that works. It's because if C here is empty, I'm referring to the mathematical notation now. So if C is empty, then something is in C is always going to be false, right? But if the left-hand side, or if the precedent of an implication is false, if the left-hand side is false, then the implication is always going to return true, which means the entire quantified expression is going to be true if C is an empty set in this case. So this part is a little bit, I wouldn't say it is counterintuitive, but it may not be what people expect. Let me give you an example. Let me give you an example. Um, okay, so this is an interesting example, and it's politically correct, 100%. It's rare for me to have to be able to think of something that is 100% politically correct. Because my mind has a tendency to think of politically incorrect things. So anyway, this one is 100% correct. So if I say every purple professor at ARC is a great professor, okay, what do you think is the value of that statement? Is it true or is it false that every purple professor at ARC is a great professor? Because the first thing people think of is, but there are no such thing as a purple professor. Because nobody is going to have a skin color of purple. And for the very few individuals with a purple color, skin color, those people may not be alive. So, they may not be able to teach or, yeah. Exactly. So Luke is right. Okay, it is true because we cannot prove it false, because there's no person, there's no individual, there are no individual who is a purple professor at ARC, which basically means the set is empty. So if the set is empty here, no one can belong to that set. No one is a member of that set, and as a result, the implication has to be true. So there you go. So true until proven false is probably the better way to say it. So I'm going to put it in the text channel. So it's going to be true until proven false. And we don't have to prove it false for like 6 items or 10 items or for every item. If there's only one thing where the predicate is false, then the universally quantified statement is false. So I'm hoping this is a viable way to explain this concept. Is basically to show it with a loop in JavaScript, and this is actual code. Okay, this is actual code that you can run in JavaScript or Node.js. Basically the same thing. They're both ECMA. They're both instances of ECMA script, ECMA script. All right, so Luke is typing something. I'm gonna wait for that. There we go. Which is weirdly at odds with the concept of justifiable belief. Well, yeah, sort of. But that's how it's defined. Okay, this is how the universal quantifier is. This is how it is defined in mathematics. All right, so if we can do something like this with, oh, here's my kitty wanting to come in. So if this is the universally quantified, universal quantifier expressed in JavaScript in code, what is the existential quantifier, in terms of JavaScript code? So we're going to take a look at that one too. All right, so let me go switch back to my terminal for typing. And I think it's this one. It's just the other tab. There we go. Okay. You guys cannot see this off the screen because I don't want to, put this part here to confuse people. So now we're gonna have JavaScript, block of code, and you guys can look up what it means to be ECMA script, ECMA script. Yeah, if you look up the acronym, ECMA script, you will find out, exactly how it is defined. Alright, so Chris just typed in the text channel, all purple professors are great professors. Implies it is not the case that there exists at least one professor that is not a great professor. That is correct. That's one way to look at it. So we can also apply the negation thing that we talked about earlier, except this time it's going to be double negation, because we have to show that we're trying to translate a a universally quantified statement by using existential quantified stuff. And so we'll get to that in just a moment. But for now, we want to write a JavaScript function for the existentially quantified expression, which is kind of like any. When we use the word any in English, that's kind of using it as for the purpose of using an existential quantifier. So we're going to do about the same thing. C is a set and P is a predicate. So in this case, it is quite opposite in a whole lot of ways. So instead of assuming the result is true to begin with, this time we're assuming it to be false to begin with. In other words, it is false until proven true. Okay, so that's how we're going to do it in the loop. The control structure is very similar in some way because it is still looking at every single member of C in this case. But the way we are changing result is, I wouldn't say opposite, but it is complementary to how we did it in the every function. So the any function is going to say result is result or P of X. So that's the difference. Where we used and in the case of every, because we want every single member to make P of X true in order for the result to stay true for all the iterations of this loop. In this case, result is initialized to false. In other words, if I want the result to be false, then I need every single element or every single member X of C to make P of X false. Because if at least one of them is making P of X true, then result is going to be true. Because once result is true, there's no way to turn it back into false when all we are doing is to say result or something. All right, so is that okay? Does everybody kind of understand, how the existential quantifier is sort of implemented in sequential logic using this particular subroutine versus, how the universal quantifier is implemented using this particular subroutine? They are very similar in many, many ways, but they're also complementary, where it counts. So this is kind of, I'm hoping this helps people to understand the more abstract concept of, for all versus there exists. I'm just looking at the text channel and it's pretty quiet right now. And of course, there's no way for me to differentiate whether it's just Discord, not working again, or whether there's really no question. I should probably sign up for another account, which I already have. So this way I can kind of ping myself, using the two different accounts, just to make sure that the Discord is still working. Yeah. Well, that's the whole idea of having everything recorded, is so that you can actually watch it again. But you can also do this. You can also play with just the JavaScript code. Okay, so if you look at this JavaScript code here, you can basically implement or test it with something like to test this logic here. You can also write an entire program in JavaScript, including both of these functions and multiple test cases and whatever predicate you want to define. And then there's a question of what program am I using for the code? It's just Node.js. You mean this part here, in the command line interface? It's just Node.js. Yeah. Yep. Yeah, it's just Node. So if I go back to the command, this is the command that I use. You can install Node.js on any operating system pretty easily. Let me just kind of go to nodejs.org. So the URL to this is nodejs.org. You can install that. You can also just kind of go, if you don't want to install anything, I think you can go to Replit, and Replit definitely has JavaScript, and you can just play with it over there. Yeah, so let me see. Yeah, you guys cannot see my URL because I usually hide the URL so I can get more screen space. But I can show you if you go to Replit. I believe it has JavaScript, so you can actually start coding in JavaScript over here. I haven't been here for a long time, so yeah. Okay, cool. Yeah, Node.js is really good for just kind of testing out things. Cool. Let's see what else. I'm just looking at the time. Oh, we are running out of time. Okay, so we didn't quite finish the quantified statements, but I think it's kind of important also to kind of go through this material slower and give you guys a chance to kind of practice it. Because with this code here, you can practice it. The other thing that I also want to show is how do we combine everything, right? So how do we make use of this function any? So I'm gonna spend maybe a few minutes so that you can end up with an actual entire program. So I'm gonna have another function here, and we'll call this function. I cannot use p anymore, but I'm going to use q. So q of x, and we can define q of x to be something that's rather simple, like what we had before. Okay, so x mod 2 equals to 0. Okay, so that's all q is going to do. So q of x is really just to ask, is x an even number? Return true if and only if x is an even number. So now you can combine any and q, and outside the context of any function, or you can define if you want to, you can have for those of you who are so used to the main function and you say I cannot live without the main function, sure, you can do it. So you can define your main function, and then just in the code outside of the entire thing, just have one single call to main. There are occasions where this is actually useful, especially if you want main to be a async function. So we are not going to talk about await and async in this class, but it's one of the reasons why you might want to have a main function, even though in JavaScript there's no need to have a main function. Whatever code that is outside of a function definition will just run by itself when you run the program. Anyway, so we can now define our object, which is basically a set. We just say one is well, in addition to unknown, undefined, there's also a value called null, which is not the same thing as undefined. But I'm just gonna use that over here. So there we go. All right. So I'm defining a local variable as here. Now we have all the pieces that we need, because now you can just say console.log, and you can now use any one of them. Since any is only any is defined here, so you're calling any, and you need to now specify what set we are talking about or what object we are talking about. That would be local variable s from the perspective of main, and then you can just pass q as a parameter. So you're passing a function as one of the arguments when you're calling any, and this time it will return, it should say true, because at least one of the members of S is a even number. Alright, so I'm getting back to the text channel. Okay, I don't know much about JavaScript, so should I have general knowledge about it? No, not really. I'm just using the code here to kind of illustrate the concept. So even if you're not familiar with the programming language, I just want you to the main point here is I'm going through every single member, and with every single member of the set C, I'm evaluating this particular assignment statement or expression. Either way, you can look at it from either direction. But the key is I'm looking at every single element, and this is what I'm doing for each element in the set, and that is the value of the existential quantifier. And that's the important part, right? I mean, so even if you don't run the code, even if you don't know anything about JavaScript, as long as you know the meaning of the for in construct. Basically, it's just going through every single member to perform a specific operation, then we're still good. So I think, if that is okay with you guys, this is all I need you to get out from the out of the JavaScript example. Yep, the logic is the same. You can do the same or something similar in C++. C++ does not let you do stuff like this. Okay, you cannot just create an object out of thin air because it's a strongly typed language. However, in C++, there is a template class called, guess what? Set. So you can use, similar constructs to iterate through every member in a set. But obviously the syntax is going to be different, and in my personal opinion, ugly in C++. Okay, this looks clean and neat and simple in JavaScript. To do something like this in C++, it's going to be ugly. All right. So if you do any lab work, you will learn JavaScript or Node.js. Yes. Yep. JavaScript is super duper useful for both back end. Well, for back end you have a lot of choices, but for front end, web stuff, it's all JavaScript. Well, it doesn't have to be, because there's also web assembly, so we can quote unquote compile anything into WebAssembly. But for the most part, people use JavaScript when they want to specify code that runs in a browser. So that's it for today's lecture. I hope this helps. And over the long weekend, okay, because we got 4 days before we meet again on Monday, so I would just kind of go ahead and install, JavaScript if you don't have, Node.js, and just play with these definitions. Just define every and any in these ways, and then just go ahead and test how they work, and just give it different objects, different predicates, run it through, and go like, okay, text said something about if you use a set that is empty, the every is going to return true. But what about any? If you give it an empty set and you say, if there exists, blah in empty set such that blah blah blah, okay, is it going to return true or false? Okay, well, I think most people can kind of guess the answer, but there's nothing substitutes actually doing it by hand and actually see how it works. I know we are out of time, okay, but I do this a lot, going a little bit over time. For those of you who can stay over time just a little bit, Node.js is also, it includes its own debugger, which is great. Okay, so I'm going to show you this, and then I'll shut up and get out of the screen share. So let me go find my screen first. There we go. All right, so Node has its own built-in debugger, and to debug, all you have to do is to say node inspect, and then whatever source code you want to debug. You kind of have to go through a very short training period. Like you can just look up the commands, okay, in the debugger. You can set up breakpoints. You can get into what they call the REPL, which is it's some kind of expression evaluation loop. I cannot remember the full name. But anyway, you can get into the debugger. Then you can actually see how a statement executes for each iteration of the for. And I think that is great, because now you can actually visualize. Oh, there you go. Read, eval, print loop. Thank you. Thank you, Chris. So the homework is not assigned. I cannot give you the assignment yet because we haven't really. Oh, I forgot. I thought that we finished the discussion of union, intersection, and difference, and we did not. Okay, I didn't get a chance to do it, so I cannot give you the assignment. So we're gonna use next Monday to finish up those notations in set before I can give you the homework assignment. Yeah, we didn't quite finish, but I forgot. Okay, I thought we did, and I remembered incorrectly. Right. So So instead of doing that homework, I'm going to have to retract the homework if it's already assigned, so I'm going to have to stop that. But instead of doing the homework assignment, I think if we just kind of focus on the quantifiers and actually fully understand what they mean, that would be great because we're going to be using quantify statements all the way through to the end of this semester. So the notations that we use in set, operations and Boolean expressions, as well as quantifying expressions, that's going to be useful all the way throughout the semester. Well, I shouldn't say throughout, but we're going to be ending this class with algorithms that make use of the quantifiers. So that means yeah, we're going to have to retain this knowledge and also use these definitions to build up more complex concepts. So if we can just kind of spend the weekend making sure that we fully understand these quantifiers, that would be great. So no assigned homework, but we just want to make sure that every concept that we have talked about up to this point are crystal clear. And then on Monday we're going to go back and talk about other operators that apply to sets. So that would be intersection, union, and difference. That's it. Yes, I did promise that I would shut up a long time ago, and now I'm going to shut up. So you guys have a nice weekend, and if you want to find me online, just kind of ping me, and I'll be happy to answer any questions, possibly with more questions. All right, bye. Yep, you guys have a nice weekend too.